Applied math friends, we're here. Last lesson of single variable algebra today. We are going to take a look at, discuss, dissect. Can't think of any other D words. Discuss, dissect. Yeah, I'll keep thinking on that. We're looking at parallel and perpendicular lines today. And these are special types of lines, both of them. A couple reasons. Parallel lines, as you can see here on my graph, are lines that never intersect. And the reason they never intersect is the following. If you take a look at the two lines here, line 1, line 2, they are going to go on forever and ever in each direction and stay the same distance apart. So line 1 has a by intercept of positive 5, up 1, 2, 3, 4, 5. And then the slope of that line is up 1, 2 to the right, up 1, 2 to the right. Second line, y-intercept of 1, but notice here it has the same slope as the first line, up 1, 2 to the right, up 1, 2 to the right. So that same slope is going to allow these two lines to always stay 1, 2, 3, 4 units apart, 1, 2, 3, 4. They rise and fall at the same slope rate of change. So in general, your parallel lines, if you have two lines that are parallel, they'll never cross. They need to have the same slope, same m, but a different y-intercept. Why do they need a different y-intercept? Well, if it was the same y-intercept and same slope, the two lines would be exactly on top of each other, and they would cross at infinitely many points, thus not being parallel. So there you have it. There's a visual. The nuts and bolts, again, same slope, different y-intercept. Perpendicular lines are two lines that actually do cross. They intersect to form a 90-degree or right angle. Now, what causes the 90-degree or right angle to form is that the slopes of your two lines need to be the opposite and reciprocal values. So what I mean by that is, if you look at line 3 here, this line has a slope of up to 1, 2, 3 to the right, so 2/3. Line 4 does not have the same slope. If you look at the values, 2 over 3 is flipped to 3 over 2, and positive becomes negative. So I'm going to go down 3, 1, 2, 3, and then 1, 2 to the right. Or I can go up 1, 2, 3, 1, 2 to the left. So positive 2 over 3, negative 3 over 2, those slope values, the rise and run, are flipped, and the sign is changed from positive to negative or negative to positive. So opposite reciprocal slopes will cause your two lines to cross, intersect at a 90-degree or right angle. We're going to continue with writing some equations here shortly. All right, the next set of examples here, we are going to be looking at given equations of lines, and we are going to do two things to compare to the given line. First, we're going to write an equation of a line that is parallel to the given line, and then secondly, an equation of a line that would be perpendicular to the given line. Now, with these general examples, there are multiple right answers. So I'm just going to give you a specific right answer here. You might be able to give me a different example that could be correct. I'll explain that here in just a minute. So A, if I want to write an equation of a line that is parallel to this line, remember the two things I need for parallel are the same slope and a different y-intercept. So if I want an equation to have the same slope as this line, I need the same number as 6. Well, there's only one number that's the same as 6, 6. But now here's where the answers can vary. I need a number that's different than -1. So I might just pick a random number like 33. Y equals 6x plus 33. These two lines are going to be far apart, in fact 34 units apart, but they will never cross because they have the same slope. Up 6, 1 to the right, up 6, 1 to the right. So as long as your y-intercept value is different than -1, and your slope is 6, you are going to have a correct answer. B, to have a line that is perpendicular to the given line, well, all I need is the opposite and reciprocal slope. So the slope here of this line is 6 over 1. So the slope of my new line is going to be the reciprocal of 6 over 1, 1 over 6, and its opposite. Since the given slope is positive, the new perpendicular line slope is negative. And again, the y-intercept value does not matter. So y equals negative 1 over 6x plus 11. Any number can be in for B, but the slope does have to be the opposite and reciprocal of positive 6 over 1, negative 1 over 6. All right, let's take a look at the second example here, same type of scenario. So I need to have a line to be perpendicular to this line, y equals negative 3/4 x plus 2. I need to have the slope of my new line be the exact same as the original line. That will ensure that the lines, in this case, fall, since it's a negative slope, at the same rate. They're going to stay the same distance apart. But now I need a different y-intercept. I'm going to go with the negative number this time. Let's just go negative 8. So I've got the same slope, negative 3 over 4, negative 3 over 4, and then different b values, 2 and negative 8. All right, perpendicular, opposite and reciprocal slope. So the opposite of a negative is a positive, and then reciprocal of 3 over 4 is 4 over 3x. And then any value for the b y-intercept is groovy. Let's go minus 2. So I've got opposite reciprocal slope and y-intercept value that is different. All right, 3, we got to do a little surgery here. First, we're going to, initially, we need to get this equation in y equals mx plus b form. I'm going to get y by itself, first subtracting 10x from both sides. So I've got 5y equals negative 10x plus 20. And then I'll finally divide all terms, both sides, by 5, and have y equals negative 2x plus 4. All right. If it helps you to write negative 2 over 1 as your slope, so you have your rise over run, go for it. No penalty for that. So my parallel line needs to have the same slope, so y equals negative 2x, and then a different y-intercept. So negative 2x minus 99. B, opposite and reciprocal of negative 2 over 1. That slope is now going to change to positive 1 over 2. And again, pick a b value, plus 86. So all that we need for perpendicular lines are opposite and reciprocal slope. We'll finish with the final examples where we need to find a specific y-intercept b value here shortly. All right, part 3, we are going to now take a look at linear equations, and we are going to write an equation of a line that is parallel to the given line and specifically goes through a ordered pair x comma y. So here, the difference from our prior set of examples is we can't just pick a random b y-intercept. We need to find that specific b value. So that's what I'm going to show you how to do here. So the key here that we are finding a line that's parallel to the given line indicates that the two lines need to have the same slope. So my given line has an m rise over run slope value of 1/2. So the slope of my new line has to be exactly the same. Oh, 1/2 is the same as 1/2. But now my line has to go through the ordered pair x is 4, y is negative 3. So this goes back to daily 9, and specifically the assignment 9.5, where we are going to write an equation of a line that has the given slope and passes through a specific point. So I'm going to use the general y equals mx plus b equation, slope-intercept form, and plug in m, x, and y into this equation and solve for b. So my y-coordinate is -3 equals m is 1/2 times x is 4 plus b. So I'm going to multiply my m and x together. 1/2 times 4 is 2. To get b alone then, last thing I'll do is subtract 2 from both sides. So -5 is the y-intercept. So if I have an equation where the slope is 1/2, y-intercept is -5, my final equation is y equals 1/2 x minus 5. So these two lines will be parallel, same slope, and the y-intercept of -5 will indicate that this line will pass through the point 4 to the right, down 3. Example 2, similar scenario here. The only difference is that my given equation is not in y equals mx plus b form. So to get y alone, I'll move positive x over by subtracting. So y equals -x plus 1. So the slope of this line is -1 over 1. So the slope of my new line also has to be -1 over 1, which is -1. And I need to pass through the point x is 2, y is 3. So I'm going to go to y equals mx plus b. Get a y value of 3, m of -1 times x is 2 plus b. Multiplying m and x together, I have 3 equals -2 plus b. Add 2 to both sides, 3 and 2, 5 positive is my y-intercept. So the given equation has to have the same slope, m is -1, and have a y-intercept of +5. So y equals -1x plus 5. We'll finish up here. Last set of examples will be the same process, only changing the slope from being the same parallel lines to the opposite reciprocal, because we will be dealing with perpendicular lines. All right, as we said, the last set of examples have the same directions. The only difference is that instead of writing an equation in slope-intercept form for a line that is parallel, we have now the word perpendicular to the given line, but then also has to pass through a specific xy point. So we need to find what is the specific b value, y-intercept, so I can find a perpendicular line. Now remember, with perpendicular, we're not going to use the same slope. So if I have the slope of -2 in my first given line, remember my new slope needs to be the opposite and reciprocal of -2 over 1, which is going to be +1/2. Change the sign, negative to positive, flip 2 over 1, 1 over 2. I'm now going to use x value of 4, y value of 7, and I'm going to once again use your friend and mine, y equals mx plus b, to find the specific b value, which will give me the full equation of my perpendicular line going through the point 4, 7. So y is 7, m is 1/2, x is 4, plus b. So I'll multiply. 1/2 of 4 is 2, plus b. To get b alone, I'll subtract 2 from both sides. 7 minus 2, b, the y-intercept is 5. So my full equation, opposite reciprocal slope, m is 1/2, b is 5, is going to be y equals 1/2 x plus 5. Isn't this fun? Oh, it's crazy. I'm so excited I don't even think I'll be able to sleep tonight. All right, last one. we need to get the given equation 6x plus 2y equals 10 into y equals mx plus b form, slope-intercept form, so I can easily identify what m, the slope is of this line. So I'll subtract 6x, have 2y equals negative 6x plus 10. Divide all terms, both sides, by 2. And I'll have y equals negative 6 over 2 is negative 3x plus 10 divided by 2 is 5. So the slope of my given line, negative 3 over 1, needs to turn into the opposite, so a positive reciprocal 3 over 1 becomes 1 over 3. So the slope of the new line is positive 1/3, and it needs to go through the point. X is 3, y is negative 5. So here we are. It's like Groundhog Day. We're doing it again over and over and over, but that's how we get better. Practice. We're not talking about a game here. We're just talking about practice. Check out the Allen Iverson, what do you call that? News conference about practice. Just type in Allen Iverson, practice. He's not talking about a game, just practice. All right. So, sorry for the tangent there, but it's a great one. All right, so I'm going to plug in y coordinate of negative 5 equals m, which is 1/3, times x is 3 plus b. 1/3 times 3 is just 1. So then to get b alone, I'll subtract 1 from both sides. Negative 5 minus 1, negative 6 is the y-intercept. So my final equation will be y equals 1/3 x plus b plus negative 6, or just minus 6 if you prefer. So there you have it. Lots to keep straight there. Again, use those notes, keep them organized, and you will be in a groovy shape. Sword of victory.